Hello my dear students, welcome back again to my channel Civil Knowledge. So today in this session we will continue our chapter, that is Introduction to Engineering Mechanics Part 2. In the last session we have learnt about what is engineering mechanics, okay, and what are the basic concept of idealization. So now we will discuss about the classification of force system. So what is force? We already learned that, right? Now what are the force system? So basically in the force system we have two types, coplanar and non-coplanar, and in that coplanar and non-coplanar we have different types of system. So this is first one is non-coplanar system. So what is this non-coplanar system? I'll explain to you, okay, one by one in the coming slides. Coplanar, just I am introducing with the names, okay. So in this non-coplanar we have concurrent, parallel, non-current, current and non-parallel. And in this coplanar it is divided into collinear, concurrent, parallel and non-concurrent and non-parallel. Okay, so now we will discuss this all one by one with an examples. Okay, coplanar concurrent forces. So as the name suggests, coplanar means what? It is a force system in which all the forces are lying in the same plane. It is what called as what? Coplanar, and lines of action meet at a single point. The lines of action meet at a single point means what? All the lines of action in which the forces are lying all will have a common point. Okay, that is called as what? Coplanar concurrent forces. So it is a force system in which all the force system, if you asked what define coplanar concurrent forces, then you have to define as it is a force system in which all the forces are lying in the same plane. If you tell the forces are lying in the same plane means it is told as what? Coplanar, and the lines of action meet at a single point. It is telling that it is concurrent. So the keyword for coplanar is the forces are lying in the same plane and lines of action meet at a single point is what? Concurrent forces. So what are the coplanar concurrent forces? So it is a force system in which all the forces are lying in the same plane and lines of action meet at a single point. See here, this xy is a plane. Here you can see the forces, one force, two force, so 3, 4 and 5. All these 5 forces are meeting at a common point, that is O. Okay, and they are in the xy plane. Okay, so what is the example we can give? The forces in the rope and pulley arrangement. Okay, so we have a pulley like this, okay, and we have a rope like this here. Okay, so here also we are applying the force. With this force, here we are dragging the force, right? So here it has this, both the rope have a common point is what? This pulley. So this is an example for the coplanar concurrent forces. Okay, next one is collinear forces. So what is this collinear? So it is a force system in which all the forces have the same lines of action. So it is a force system in which all the forces have the same lines of action. See here, F1 and F2 are the two forces and the lines of actions are same. See, the line of action is same. The arrow represents the line of action. So this F1 and F2 may be like this also, no problem. See, here till this is a force called F1 and from here it is called F2. So what is the line of action here? Line of action is like this. Okay, it may be tilted or not anything, but it should be in both the forces, or if we have n number of forces, that also okay. F1, F2, F3, they all should be in the same line. The line of action should be same. So that type of forces are called as what? Collinear forces. So what is the example we can give? Examples: forces in a rope in a tug of war. Okay, so what is this tug of war? It is a game. So in the tug of war, so people will be there. Here are some team of people. Here also one team of people. Okay, this both will have a rope Okay, these both are holding a rope. Now this rope should be, they should pull these people to this side, and these people will have to pull these people this side, like this. Okay, so these many members will be there, so more than 2 to 3 members will be there, and the force of each person holding that thread or holding that rope will be in which direction? So these people direction in the same line of action. The line of action should be like the thread only. Understanding? So the in the tug of war game, these people will try to pull these people to this side. These people will try these people to this side, right? But they are applying the forces on the rope. So that rope is the path for that line of action. So there we can tell that it is a force system in which all the forces have the same line of action. This person's line of same action is, or in the same line of action, this also same, this also same, this also same. Okay, the direction may change, but they are all in the same line of action. That is the path of that rope. Okay, next one is coplanar parallel force. Okay, so coplanar means what? Coplanar means what? It is a force system in which all the forces lie in the same plane, so it should be parallel. So you can write like this also. It is a force system in which all the forces are lying in the same plane and have parallel line of action. So see, xy is a plane. So these are the forces, but they are parallel to each other. Whatever may be the direction here, okay, but they will not coincide with each other. They will not cross with each other. They are all parallel to each other. So what is coplanar parallel forces? It is a force system in which all the forces are lying in the same plane, that is in the same plane, and have parallel lines of action, are called as what? Coplanar parallel forces. So what is the example we can give? The forces are loads and the support reaction in the case of beams. Okay, so if we take a beam, so your first here, so consider this as a beam, right? So in the beam we have support, in the support also we have a reaction. Okay, here also if we add weight we will have a reaction. So this beam is supporting, means wait, so suppose you are placing a, so consider this as a column. Okay, this is a column and this is a column, or this, consider this is a table. Okay, this is the tabletop, this is the tabletop. Okay, so tabletop is supported by the table legs, right? So this legs line of action will be like this. So because it is holding the table weight, right? It is holding which weight? It is holding the, it is holding this weight, this table weight it is holding. So I am representing this leg as like this. Okay, if we sit on the table, if a person sit on this table, so his force will be towards the gravity, right? Okay, so this force and this force, how are they? They are in the same plane. If we take a plane here, they are in the same plane, so it is called as what? If the forces are in the same plane, they are called as coplanar, and they are also parallel to each other. So this force, what I am showing here, so this force is parallel to this force. See, legs force, and this force is parallel to this force, and here the weight of the person is also parallel to this force. Weight is like this, leg is upward, reaction is like this. Okay, so these are called as coplanar parallel forces. So next one is non-coplanar parallel forces. See, as the name suggests, only non-coplanar. So it is a force system in which the forces do not lie in the same plane, we should say. when it is non-coplanar, right? The force system in which all the forces are lying in, are they do not lie in the same plane, but they are lying in different planes. See, and still have the parallel lines of action. Okay, if we consider that table as in 3D form, see, x, y, z. In the earlier case, we have only x, y plane. Here we have x, y and z plane. We have what? X, y plane, y, z plane and z, x plane. 3 planes. So 3D. Okay. It is a force system in which all the forces are lying in the different planes. Okay. They are not lying in only one plane. They are lying in the different planes and still have a parallel line of action. See, the force here, this is also parallel to this force. So this force is also parallel to this force, but they are not intersecting to each other. Okay, they just move upon. They will not intersect. So this property of that line force is called as what? They have parallel lines of action. Okay, so the forces acting and the reaction at the points of contact of bench with floor in a classroom can be an example. Okay, so whenever you sit on a bench in your classroom, so consider this as a bench. Okay, the forces acting and the reaction at the point of contact of the bench with the floor. Okay, so if we consider this as a floor, wait, see, if we consider this as a floor, and here you have a bench on which you sit. Okay, see, so between this floor and this bench we have a reaction here. Okay, this also we have reaction, and between where you sit, no, there also we have one reaction. Between you and the bench we have one reaction. So in the 3D we can assume that your reaction will be towards the x-axis and the weight in the direction of y will be in the z-axis, and bench acting in the floor be in the z-axis. Correct? The weight will be always towards the center of the earth, that is g. Okay, gravity. So like that, imagine. Okay, so what is it is a force system in which all the forces are lying in the different planes. Whenever they ask, the forces are lying in the different planes but still have the parallel lines of action they can give. It is explained as what? Non-coplanar parallel forces. So if we ask example, the forces acting and the reaction at the point of contact of bench with the floor in a classroom. We can give an example for non-coplanar parallel forces. Next one is coplanar non-concurrent forces. Okay, so it is coplanar means what? It is a force system in which all the forces, whenever it is coplanar, what is the keyword? All the forces are lying in the same plane. Non-concurrent, the forces are lying in the same plane but they are not meeting at a point. Concurrent means meeting at a point. Non-concurrent means they are not meeting at a point. So what is the definition? It is a force system in which all the forces are lying in the same plane but lines of action do not meet at a single point. See, the forces are in the same plane, xy plane. Okay, they are in the xy plane but they are not meeting at a single point. So what example you can give? So if you go to market, so if this is a person of R, A, B, C, D. Okay, so in this market when they go, okay, this all the persons, the law of attraction. So he is going to buy sweets, he is going to buy something, he is going to buy something, he is going to buy something. They all are going to buy their own items. Okay, they will not meet at a single point but they are in the market. Okay, they are in the same plane called market. Okay, understanding? It is a force system in which all the forces are lying in the same plane. They are in the lines, they are in the same plane but the lines of action do not meet at a single point. We call as what? Coplanar non-concurrent forces. So example is forces on a ladder. You can give this example also, or the forces on the ladder and reaction from floor and wall when the ladder rests on a floor and leans against a wall. Okay, the forces on a ladder and reactions from the floor. So whenever floor is there, no, so when ladder is there, so I'll take this as a ladder. Okay, so on this ladder forces will exist, correct? Okay, but due to these forces reaction will also generate, correct? Here reactions will also generate. So in the same plane we can see the different types of reactions and also the forces on the ladder which leans against a wall like this. Okay, you can take this example for understanding. In the engineering we have to give this type of examples, right? So coplanar non-concurrent forces. So next one is non-coplanar concurrent forces. See, here the forces are non-coplanar but they are concurrent forces. Means what? It is a force system in which all the forces are lying in the different planes. So whatever the forces are there, they are lying in the different planes. They are not lying in the same plane. See, they are not lying in the same plane. They are lying in the different planes, but still they have a common point of action. Okay. So in the city, you can take this as a circle. Okay. Whenever an important circle will be there, no, so wherever you go you have to come and you have to go by circling that circle. Okay, if any important circles are there in your town, means we have to go through that circle to a destination point where you want to go, right? So like this, 1 minute. So non-coplanar concurrent forces. So it is a force system in which all the forces are lying in the different planes and still have a common point of action. Here all the forces are lying in the different planes. In xy direction also you can see forces, and in xz plane also you can see the forces. See, here also one force is there, here also one force is there, and here also two forces are there. Here two, here two forces are there. Their line of action may not be same, means their direction may not be same, but they are meeting at a point, correct? So it is a force system in which all the forces are lying in the same, lying in the different planes but still have a common point of action, is called as what? Non-coplanar concurrent forces. Okay, so next one is non-coplanar non-concurrent forces. So here the forces are not only in the same plane, they are in different planes and they do not meet at a point also. So it is a force system in which all the forces are lying in the different planes and also do not meet at a single point. So by the name itself you can define the different types of force system and you have to write in your exam. So what you can give an example or diagram, you should write these three planes, that is xyz plane, and you have to simply draw the force of action. Okay, these all the forces are lying in the different planes but they do not meet at a single point. So whenever they are lying in the different planes, they are called as what? Non-coplanar, and they do not meet at a single point, non-concurrent forces. So non-coplanar non-concurrent force system. So forces acting on a building frame. So in a building frame, if we take a building, so the forces will be like this. They are in the same building only, but they do not meet at a single point. We will learn it later. Okay. So next is, so principle of physical independence of forces. Now the name suggests it is the physical independence of forces. This principle states that the action of force on a body is not affected by the action of any other forces on the body. Okay, it means that, so it states that if a number of forces are simultaneously acting on a particle, if a particle is there, so many forces are acting on that particle. So let me take A force, a B force, C force, like n number of forces are acting on a particle. Then this each one of the forces, then each one of them will produce the same effect. So A will produce its same effect, B will produce its same effect, C will produce its same effect, which it would have done while acting alone or independently. Okay, so if all the three forces coming and acting on this particle and getting the effect is same, if the forces are acting together or they acting individual only, the same effect will happen. Means if a square is there, a particle square is there, okay, so if we add the forces like A, B, C, if three forces A, B, C, wait, I'll clear this. If a, see here, square is there and on that square I'll try to show three forces, that is ABC. This ABC force is acting on this square, okay. So upon the effect of the square, after this ABC force is acting on that particle, this square will become what? Circle. Okay, assume that this square will become circle. So the ABC force effect will be there on this square to become what? Circle, right? If the ABC force at once they are acting on the square to produce circle, okay. If suppose this square is first it is affected by A force, then it will become like this, okay. Then it is affected by B force, then it will be like semicircle, okay. Then it is affected by C force, then it will be full circle. So whatever the effect should be produced by the A force, that effect will be produced when it is acting. Whatever the effect which it would be produced by the B force, it would be produced. Whatever the effect produced by this C force, it would be acted on that particles to make that what? To make that particle circle. So the principle of physical independence of force is what? The force which is acting on that particle will produce the same effect either independently or in a group. It will produce the same effect. So this is they are telling. So this is your principle of physical independence of forces. What it again you see the statement. It states that if a number of forces are simultaneously acting on a particle, if number of forces are simultaneously acting on a particle, then each one of them will produce the same effect. Each one of them will produce the same effect which it would have done while acting alone or independently. Okay, so this is the principle of physical independence of forces. So we'll see the next topic, principle of superposition of forces. So here in this law, it states that the action of a given system of forces on a rigid body will in no way change if we add to or subtract from them in another system of forces in equilibrium. Okay, it means that, see here, so this is a picture of a playing tug of war. Here see, a person is holding the thread and this is the line of action. Okay, two persons are holding here 50 Newton force, 50 Newton force, 100 Newton force, 50 Newton force, right? So total is here 150 Newton force. Here it is 100 Newton force. Of course, they are the winners, but see here, concept is this is the force system, yes, and this is the force system in equilibrium, yes one. So what is this force system in equilibrium? See here, here the persons are pulling this thread, but the force is applied 75 Newton and here also 75 Newton. So same amount of force is applied. So they will be in stable form, right? They will not move. Okay. So now here in the law of superposition, what they tell means, see, if a system of forces, say yes, okay, shown in figure is acting, and if we superimpose another system of forces S1, so on this system force of S, we are making this person to come here and to this person to come here. So same type of action, so same type of force, we are making them to join here in the force system S. Now what will happen? See, superimposing the, if a system of forces, say S shown in figure, is acting, if we superimpose another system of forces S1 which is in equilibrium by itself, so they are in equilibrium, right? Then the combined effects of S and S1, the combined effect, this S and S1 will be the exactly the same as that of the system S as in the figure. So see here, 100 plus 150, okay, adding is what, 75 we added here. Here also 100 plus 75 we have added. So adding this 75 will not make any difference in this system. Yes, this they are telling here. So by this effect of superimposing, we will not decrease or increase the effect of that force system, but we will manage to make that system of forces in equilibrium as it was in the initial stage. See, what I am trying to tell you is, in the initial stages, so here in this initial stages, so here the force was 150 Newton, 50 plus 100, here it was 100. So we added 2 persons again which are capable of handling 75 Newton, right? So by adding this means we are superimposing these people are here. If we add this superimposing, that too of same quantity, here and here, they people, so they are in equilibrium, right? They will not make any change in the effect in the force system. Yes, so this is the principle of superposition of the force, that the action of a given system of forces on a rigid body will no way change if we add to or subtract, okay, if we add to or subtract from them in another system of forces in equilibrium. Okay, this is the principle of superposition in force. So here I conclude today's session. So the next topic will be dealt in our next sessions. Thank you.